All right. So now we're doing FreeCodeCamp Legacy Python for everybody. Build your own functions. All right. We're also going to be doing the exercise in the next video. Let's go.
So welcome back. We're going to continue and start talking about building our own functions. So
all right. So let's start with this. Let's get out the notes. Boom. Go to the bottom. There we go. And let's start typing this stuff down. So building our own functions. Building our own functions. Let's do it. Building our own. Our own functions. Is this a new? No, it's not a new chapter. I think the exercises are at the end of each chapter. I'm pretty sure that's what the little pattern is that we're witnessing. All right. So building our own functions. So we create a new function using the def keyword, followed by optional parameters in parentheses. All right, so let's go over parameters because that should be defined before using it, honestly, but whatever, that's what this video is for. So a parameter, okay, this isn't good. Okay, so inside of functions, when we declare functions, like let's say this is just an example. I'll put an example. EX parameter example. How about that? Very verbose. Parameter example. All right, so let's come down here and let's say we're building a new function. Remember, they look like this, like def and then the name of the function and then do whatever. Okay, so def parameter. Yeah, there it is. Parameter example. Remember, we can name these anything we want. All right, so then we put the little parentheses and we have this. The parentheses indicates that this thing's going to be a function. Also, I'll show you in a second. So down here, what we want this to do is we want to, we're going to pass, remember the arguments things for like with print, how like right here, print. Remember how this is an argument and we're pushing it into here and the print function is now going to push this. It's now going to print this out in the console, right? So over here, we're going to say something like name, okay? Name like that. And you see, it's just like a variable. It's just lowercase. It's just like a variable. It's basically exactly like a variable, but it's inside of a function, all right? So we're going to say name. We're going to say print hello. We'll put hello space like this, and then we'll say name. And I'm pretty sure we'll say plus name like this. And I'm pretty sure they do say that we don't need the spaces, but I'm not that used to Python yet, so I'm going to put the space there anyway. So right here, what it's going to do is when we call parameter example down here, like we say parameter example, and then right here for the name, we'll say, actually, you know what we should do? Will we include that? Okay, check this out. We could say outside of this, right here, we'll say, let's bring this down. You know what we can say? We can say input, and then the input will be, let's say, question. Let's call it question. Question equals inputs. What? And then we'll say, what is your name? All right. And then down here, we'll run it. We'll run, we'll run this. We'll say parameter example question. All right. So basically, I made this a little bit complicated, but it's the same thing. Okay. So we've got this thing right here. Okay. This is all inside of our program that we're going to run. We're going to call this program example.py, whatever. It doesn't matter. All right. And so this is what's saved in our example.py, def parameter, example name, right? So parameter example name. So this is the function right here, okay? And it's going to print hello name. So when we say question input, what is your name? And then we run the thing. When we run, when we do this, like let's say, I mean, I just think this is a little bit better. Anyway, so let's say we have these like two angle brackets, like when he's running his little command lines. And it says, we say, what do we say? We say Python, and then we say example.py. Example.py, right? We just ran the program, right? We're already inside wherever file directory we need to be, and we're running the program, okay? So now on the next line, it says, what is your name? And then you type in, I think maybe you type it in here. I don't know. Oh yeah, let's put a question mark in the space. Yeah, because we have done inputs before. All right, what is your name? We say code man S. And then when it runs, it goes, I don't know if it does it like this or if it just does it like this. Oh, remember the example? The thing he did earlier where he had the angle brackets and then we had to see what the min and the max was. Yeah. So when it answers, it'll say, hello, code man S. Let's add a little excitement to it. How about that? Hello, code man S. Boom. And so this is basically what would happen, right? And so the parameter is this thing, okay? It's the variable inside of a function definition, right? So this is the parameter. We'll pass it in here, right? What is your name? That's the input. Maybe we should call this answer. Maybe we should call this name. How about that? Wouldn't that be a little easier? Name. Whoa. I forgot this is in the text editor. Name. Okay, so name right here. Okay. So it passes in. What is your name? Hello. Oh no, we can't use name. Or can we? Oh yeah, we could actually. Technically, we could. No, yeah, we could because this. Okay, so this is local scope and this is global scope. So because this is local scope right here, this local scope supersedes the global scope. Okay, so right here, name and name can be used, and also we can say name right here for a variable. It's a little confusing, but this actually would work, huh? But this name and this name are not the same name, and neither is this. This is a string name, okay? Anyway, so yeah, this is basically what a parameter is. It's a variable inside of the function declaration, right? So this is, we pass in name. It used to be question. Remember, this used to be question. It can be anything we want. So we pass in name as the name in parameter example, and it'll say hello name, right? And so the name we passed into it was the input, which turned at this turns into code man S. I don't know if this is too verbose or if this is on point, but whatever. Anyway, so there's that. Let's get back to writing the next line. Maybe I can give you a whole sermon on that. We indent the body of the function. I don't know if I went too hard on that or not. Function, but it needs that we need to know what a parameter is if we're going to say parameter. That's my basic. That's basically what I'm getting at. So now you know what a parameter is. Um, maybe I should leave all this into one. Oh, this is part of it. Oh, you can't do that. This isn't a text editor. Anyway, whatever. Next is this. This defines the function, but does not execute the body of the function. Yes, building our own function. Okay, so yeah, this right here. Let's put an example here. How about that? Ex. Let's say def. Let's just go down here and tab it over there. Def print lyrics. All right. So we're defining the print lyrics function. We're going to say print. That's what we'll print. 1 and print 2. Like this. And we'll say anything we want. All right, there we go. So yeah, basically, that looks terrible though. Oh, but it's not a text editor. Lyric 1. Is that even a lyric? Is that a stanza? I'm not that smart. I'm not that remembering. I'm not trying to remember that. Lyric 2. Okay, there we go. So yeah, just because we defined it doesn't mean it's going to get called. The only way to get this thing to actually print 2 lyrics would be to call it by saying print lyrics, but we'd have to do it like this way up here, like that. And I don't feel like typing that out right now. So yeah, this doesn't do anything unless it's called. That's what this is trying to get at. All right, so let's listen to Dr. Chuck talk about it. 12 minutes in and we just started the video. All right, let's go.
Again, we use the def keyword to define a function, and then later we're going to invoke this. And there's a bit to it. We are defining the name of the function. In effect, we're extending Python and creating new predefined things that we can use, except it's our code. It starts with a def keyword, has some optional arguments, which we'll see in a bit. That's what the parenthesis is. And then the name. And the function names follow the same rules as variable names. And then you have an indented block, whatever code you want to do, and then you have a de-indented block, and that sort of defines the essence. The key thing here is this is not calling. It's not invoking. It's not executing. It's remembering. It's storing. It's figuring things out.
Yeah, it's not doing anything.
So here is the output of a program that defines...
All right, let's look at this. Let's type it out, honestly. Let's type it out because it's good to get some experience typing, typing this stuff. So let's type it out while we're at it, just to get some extra experience. We can call this example 2. We'll deal with this part later, but let's do this part first. All right. So let's say ex2, ex2. All right. So we've got x equals 5. X equals 5. All right. Print. Print this. No, that's not. Oh yeah. And inside here we'll say hello. Hello. All right. Go to the end. Press enter twice. Tab it over once. Def. Print underscore lyrics. Boom. 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 All right, so let's do 2 tabs on the next line. Print. There we go. Lyric 1. And then we'll do print. What is this? Lyric 2. All right, there's that. And then we'll say print yo. You got it. Hold on. What's going on here? Okay. What's going on here? Why is it doing that when I press tab? What's going on? Anyway, whatever. Let's get rid of this. Enter twice, tab, and then we'll say print. Da 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 yo. All right. Then we'll press enter, x equals, whoa, tab, x equals x, well, that's not equals x, that's s. Come on. X plus 2. Typing's hard. Print x. All right. Anyway, so let's go over this. So yes, this, I guess we could call this a program, but it's a whatever. All right, so we're saying print hello, right? We're saying x equals 5. Print hello. Print lyric 1 and 2 is in this thing right here. Print yo, x equals x plus 2. So x is 5, x plus 2, so it's going to print 7. All right, so that's what gets printed. Nothing gets printed because we didn't call it. We'd have to call print lyrics for it to print the lyrics, which it won't because we didn't call it. So yeah, this is basically just taking up space right here. It's like a hidden function. I mean, you could like have another program that calls that. I don't know if that's possible or not. Have another program that calls this dormant function inside of another program. I don't know if that's possible. I don't actually, now that I think about it, I don't think that makes sense. Unless you could. Anyway, that's deep. That's deeper than I have traveled. Let's go. Let's go now.
But then doesn't use.
Oh, let's back it up. What is this? Print lyrics. This. Okay, this is pointless, I guess. I don't know what this is for. All right, let's go back.
This is here it's not executing, it's remembering, it's storing, it's figuring things out. So here is the output of a program that defines a function but then doesn't use it. So this is a sort of broken function. So here we go. We start executing.
Pointless, I would say.
You don't have to you have all the defs at the beginning. The def runs whenever. So, out comes hello. And then we define a function and this says, oh, you want to make a new thing here. So I'll make a new thing. It's kind of like a variable in a sense. And then it copies this stuff, copies it up there and says, later you probably are going to want to use this. So I'm going to remember it. So it doesn't do anything there. No output comes out. Then it says print yo, and out comes yo. And then it adds 2 to x, so x is now 7, and then it prints x, and there's no 7. There's 7. These print statements never ran. They never ran. Why? Because we did not invoke them down here. We defined them, but didn't invoke them. So let's take a look at how you invoke a function.
All right, how we call a function. All right, let's do it. How we call a function, because we're not Harry Potters. We're not Harry Potters. Definition and usage. If you feel like you're a Harry Potter, you are on the wrong channel, buddy. We are not Harry Potters around here. Definitions and usage. Definitions and uses. There we go. There. All right. Once we have defined a function, buckaroo. I gotta edit that out. Remember to edit that out. Edit that out. All right. I don't know why I would tell myself, hey, edit that out. Who do you think you are? Oh yeah, me. Once we have defined a function, we can call it. We can call it as many times as we like. All right. This is the store and reuse pattern. Okay. So once we've defined a function, we can call it as many times as we like. Yes, it's just like any kind of variable. It's like a variable that does something. I mean, that's what a function basically is. It's like a variable that instead of equaling like just a value, it equals a code, like a program, a mini program. Anyway, And this is the store and reuse pattern. All right, so there's that. Let's see what Dr. C has to say. Probably we can invoke this as many times as we invoke in one.
And then you use it. Sometimes you define it once and use it once, but more commonly you define it once and use more than one time. Again, the store and reuse pattern. The def is the store, and the invoking is the reuse.
Calling.
So here's just a slightly different version of that last.
All right, let's see what we got here. It is the same, slightly different. Let's pull this up and let's practice how we change code slightly. All right, so we got example 1, example 2. Do we have any more examples? Example pi. We can, it doesn't matter. We'll call this example 3. Let's copy this from this up to here, right? Do it backwards. That way you know where you ended. Or something like that. I don't know why I like doing it backwards. Mainly because I'm usually like reading down here. And so my cursor's here. And so let's just go backwards. All right. So what are we doing? We'll drop this. Did we get example? All right, let's change it to example 3. All right, good. Same. Print yo. Okay, we'll go do print lyrics here. Whoops. We'll say print lyrics like that, and then we'll do the same. Okay, and so it's gonna. I didn't do the return. Let's do that too. We'll say, man, I wish we could tab it all over. Watch. Boom, boom, home, boom. All right. And let's call this what was I doing here? We're calling this print lyrics1.py. Lyrics1.py. All right, let's do that. Oh, no. I remember what I was doing. We'll say program tab output. There we go. And then let's no. That's cool. Now let's bring this back one. Go to the end, tab it over. All right, so the output of this is going to be hello, yo, and 7. So hello. 1, 2, 3, 4. Yo. 1, 2, 3, 4, 5, 6, 7. 7. All right. So this is the output, right? And so over here, we've got this. Hold on. I got to tab it all over again. One day I'll have this down to where it's not terrible. I mean, I don't think it's too bad. I mean, come on. It could be worse, right? So let's say program, tab, output. Okay. So yeah, this is going to give us, maybe I should have just copied and pasted. Actually, I should have done that. Hello. We'll come down here. What else? What's next is Joe, the lyrics. Hello, and then 1, 2, 3, 4, 5, 6. We'll say lyrics. All right. Is that what it was? No, yo. Yo. And then after that, we're going to have lyric 1. Then we'll have lyric 2. Hold on. Look at this. All right. And then we will have 7 as well. 7 again. Like that. So this is going to be the output. When we call the function right here. All right. And remember, this is just practice. Like doing stuff like this, the reason I'm doing this is just to practice being able to do this better later, because it's good to know how to like manually format things to make it look, okay or decent. Is this on the same line? This needs to go down. This all needs to go up. All right, let's do that. Oh, I can't do that. Whatever. Oh, that sucks. It's stupid looking. Whatever. We'll bring this down. How about that? All right, let's do that. Whatever. I don't care. It is what it is. This looks better than having to try to put all these up there. All right. So anyway, so yeah, it's the same thing from before. We added the print lyrics thing right here. So it prints out lyric 1 and then lyric 2. Okay, because that's what the function's telling it to do. And then it does 7 at the end like that. Real cut and dry stuff. Let's listen to Dr. C talk about it.
Program, and so now it's going to actually invoke it.
Call it.
So x equals 5, print hello, def, so out comes hello. This produces, the def produces no output, right? But because there's a D indent here, that is the entire blob of the code that is part of print lyrics. So it prints out yo, and now we're going to invoke. This is the call.
Call it.
We're going to call the function.
Yes.
Now the function goes up. Let's clear this. So we're down to here. Now this like suspends at this place. It's like remember to come back to here when we're done. Go up, run this code, and then come back, and then continue on. So it like leaves like a breadcrumb of where it's supposed to come back to, and then it runs, and then
I'm telling you, I don't know what he's talking about. I mean, I know what he's trying to say, but I don't know why he doesn't say. It's just a variable that does something. That's all it is. It's a variable that does something. This, instead of declaring it like this for a static variable, this is more of a dynamic variable, and you declare it with def, print lyrics, and this, and it does something. That's all it does. It does something. All right. Yeah, that's it. It does something a little more complicated than this. I mean, is this a function? I don't know. Anyway, so let's keep going.
The print lyrics, of course, produces the 2 lines of output. And yeah, that should probably not have, that they should be up there. And then x equals x plus 2, which makes it 7, and then prints out 7. Okay, so this is the
calling.
Invoke or call the function.
Just call.
Okay, you defined it, and then later you called it. Now.
All right, calling. I don't know why he's having such trouble with that. It's just so easy. Just don't say something that you would read in a Harry Potter book. Okay, it's that easy. Let's go up here. Magic. It's so stupid. It's so stupid. It's what makes people lazy, because there's no magic. Get your fingers on the keyboard. Either get your fingers on the keyboard or get your hands on the shovel. Okay, that's what it's all about. That's life right there. Arguments. You better start working. There's no magic. An argument is a value we pass into the function as its input when we call the function like that. Yes, we've done this before. Like here's the max. This would be the argument right here. We know what an argument is, right? So let's go to the next part. We use arguments so we can direct the function to do different kinds of work when we call it at different times. What did that say? We use arguments so that we can direct the function to do different kinds of work when we call it at different times. Yes, absolutely. Like maybe we want to do the max of hello world here, but down a little bit further, we want to do the max of of something we haven't talked about, of a list of values. All right. We'll get into that. That one's a teaser right there, because it's not written down. So we put the arguments in parentheses after the name of the function. True. So this is how we call a function. Is we have the name of the function, the parentheses, right? That's how it knows it's a function and not a variable, and a static variable, I guess. Let's just keep calling them variables. And that's it. Let's see what he has to say. Did we type the third one? No. What? We put the arguments in parentheses after the name of the function. All right. Okay, yeah, so we went over that. Blah, let's go.
In addition to just call and return and
you know what else?
Invoking, we can pass parameters in. And the example of the parameter is in the max function, we have to say, this is the thing I want you to find the maximum of, the largest thing. And
that's the argument.
Part of it is,
look,
in the whole
he said parameter, but he's talking about arguments. Okay. Because there's not a single parameter example or word on this page. So he was just talking about arguments. Just helping you out there, Dr. C. All right. Because I do the same thing. I do that plenty. You've seen my videos.
Store and reuse pattern, we have a few lines of code, but sometimes we want to do ever so slightly different things in a different invocations. And so we use the arguments to subtly adjust, like finding the maximum is a general thing, but what thing to find the maximum of, that makes a function that's much more useful and reusable in a lot more situations. So arguments are the thing we passed in, and we define for our functions that we're going to build, we on the def statement.
Here it is. And look, it's a P for parameter. I wonder if he did that on purpose. Anyway, parameters. Let's type this up. I bet he did. Because that looks like a P, right? Anyway, that looks like a P, right? It's got to. Let's go. Parameters. Parameters. Let's see what this says. A parameter is a variable, variable which we use in the function definition. Yes, that's what I'm thinking. That's what I say. It is a handle, okay, that allows the code in the function to access the arguments for a particular function call. I don't know. Look, I thought I knew what a parameter was until I read this sentence right here. And now it's like, what's a parameter? It is a handle that allows the code in the function to access the arguments for a particular function invocation. That's terrible. That's okay. You know what? No. Okay. This is what it is. A parameter is a variable which we use in the function definition. The reason I'm saying no to this is because it starts with a handle, but then it doesn't say it's a door or it's the handle to a drawer, or is it the handle to a pot and a pan? You know, what kind of handle are we talking about, right? So this is, I'm helping you out, Dr. C, all right? This is a bad whatever it was trying to be. And what a parameter is a variable which we use in the function definition, right? So we've got this def greet lang, right? So lang, this is the parameter. What? Yeah, this is the parameter, of course. All right, so whenever they type something in here, like en, es, or fr, if lang is es, we're going to print hola. If it's French, we're going to say bonjour. Else we'll say print hello. All right. So for English, it's going to go hello. If it's Japanese, it'll say hello. If it's Russian, it'll say hello. If it's not Spanish, if it's ES, it'll say hola. If it's French, it'll say bonjour. But if it's anything else, it's hello. So yeah, that's how this little function works. This is the lang. This is the parameter. Pardon me. This is the parameter, which is the variable that we use inside the function, right? So whenever we pass something in, that's what the variable now equals. So lang equals in when we do it like this. And now here lang equals s when we do it like this. And there we go. So that's how parameters work.
So we say def, greet, name a function, and then this is the arguments, the things that are coming in. Now, this lang variable, in a sense, only exists during the life of the function, and it represents sort of a placeholder. It's not a real variable in the same sense.
True.
It's a placeholder that refers to how you touch that first parameter that's sitting in there.
True.
Okay, and so lang...
But at the same time, for all intents and purposes, let me do this. Start. Where's the stars? Start. Okay. I didn't type this down. So whatever. Just lang equals, so it's like this. All right, we're not going to keep this in there, but it's just like this. Lang equals ES. No. Yeah. So basically, when we do greet ES like that, basically lang equals ES now. So lang now equals, come on now, ES. This stuff is, it's not, look, grab the microphone or grab a shovel. That's how it is. All right. So greet ES is the same as saying language in lang here now equals ES. All right. Whenever we do this stuff. All right. So it's just like having, I don't want to write this down. We had fun typing those other examples out, but I don't want to type this one. All right. So let's keep going.
So lang is our first parameter, whatever it is. We don't need to see this part down here right now. All we know is we're going to make a function, and we're going to take a parameter, and this lang is the placeholder that tells us what that parameter is. Okay. So within the function, we're going to check to see if the language is Spanish. If we are, print hello. Else, if the language is French, print bonjour. Otherwise, print hello. We have a very highly simplified language translation system here. So the def, of course, does nothing except remembers that and defines the concept greet. So that comes down, and now we're going to call it. And that says, go look up the thing that I defined called greet. If you don't put this in, greet is going to give you a traceback. But because you extended and named it greet, so it runs in, it starts, suspends the code here, starts up here, but then lang is now an alias to en. So now we can run if that is es, else if, I'm getting it all wrong now. All right, so en comes in as lang, we're coming in the code. If it's not es, it's not fr, else it prints hello, and then it comes back to the next line. And then we call it again, and this time es is lang, and so it runs this code and prints hola, and then next time it calls with this, and then it prints bonjour. You get the idea.
True.
So
that's basically what happens.
Is a placeholder so that on the successive calls or invocation of the function, we can get at whatever the programmer put in as that first parameter. And so we are saying in this definition, we are ready to receive a first parameter. Please call us with a parameter, and then we will be able to do something slightly different for the different values. So this is a reusable bit of function that prints hello in 3 different languages, and then we tell it what language at the moment that we're actually invoking it.
Calling.
So that's putting stuff in.
All right. We'll go back to this part, and then we'll go, actually, let's go here, and then we'll go back. All right, so now let's type his return values. I just looked. It's like 40 minutes, and we've still got half the video to go. I really need to quit. I don't know, but the thing is, this is really, as long as this is taking, it's still solidifying. You know what I'm saying? Even though I do know most of this stuff already, but whatever. It's good. It's always good to do more, I guess. Whatever. Return values. Okay. So now, often a function will take its arguments, do some computation, and return a value to be used as the value of the function call. There's got to be a way to make this like a 10-word sentence. Come on. In the calling expression, the return keyword is used for this. I'm pretty sure I know what he's saying, but I didn't. All right. Often a function will take its arguments, do some computation, and return a value to be used as the value of the function call in the calling expression. All right. What? Look, I know what a return value is. It's just, I don't know what the sentence is. But the return keyword, okay, what? And return a value to be used later, to be used as the value of the function call in the calling expression. To be used as the value of the function call in the called expression. Often a function will take its argument, do some computation, and return a value to be used. And return a value. Return a value. We don't need all this. The return keyword is used for this. Okay. Okay. So returning a value is basically what the function equals once it's done doing its thing. Right. If once it returns whatever you want it to return. Okay. We could have greet Sally, greet Glenn in the thing, and if it just returns what am I trying to say? Yeah, we could, like, let's just say in here it's like print Sally and print Glenn are in here, right? And then we could say return 32, and whenever we run greet, it doesn't matter what we would put in as the arguments. No matter what, it will return 32 because that's what we told the function to return. We could have all the nonsense, ridiculous code we want inside the thing. It isn't, if we tell it to return something completely different, that's what the function will return. Right? So that's what returning means.
Into the function, now getting stuff back out.
Oh, let's back out.
So that's putting stuff into the function, now getting stuff back out.
True.
Is the concept of returning. In the return statement.
Yeah, returning is getting something out of the function. All right, let's go.
The return statement is an executable statement that does two basic things. The first thing that it does is it finishes. Now this is a one-line function, so that's kind of redundant, but when Python goes into the return statement, it doesn't continue on.
Let's look at this. I didn't even bother looking at this. All right, so let's say we got this def greet, right? So this is the definition of the function greet, and it says return hello, okay? So when we say print greet, the calling of greet, and it doesn't have any arguments or parameters, we'll say greet, and then we'll say Glenn, and now it's going to print out hello Glenn, and then when we do greet Sally, we'll have hello Sally. All right, so let's keep going. On
to the next line. It just returns. That is the end of the invocation of that particular function. But even more importantly, it takes as its parameter. You can say return without a parameter, and it will stop the execution of the function, kind of like a break does for a loop. It's kind of a break for a loop.
We haven't even got into loops yet. If you guys know what a break is, we know what a break is, but we haven't even gone into loops. All right, let's go.
Run that next line, get out. But it also allows the specification of what you want as the residual value in an expression. So we're doing a print, and then we're saying greet, and what's going to show up here is whatever this function does in its return statement. And so that prints hello. We call it again, and it prints hello again. Okay?
Yes.
And so basically the return statement is I call this the residual value. It's like what shows up here when the function is all done, and it's the string hello. We call the function.
All right. Let's do this. I want to make a two-parter. But all that stuff I said, I think is really will be useful to somebody. So let's keep going. This is where sometimes I got stamina issues. Return value, especially when it comes to like this stuff that needs a lot of endurance. Return value. Let's do this. What? Wasn't the last one return values?
All the functions that return
value. Yeah, return values, return value. Well, you know what? I guess it's hard to be a university professor also. Return value. Let's do this. A fruitful, I am running out of gas fast, function is one that produces a result or return value. What's that say? A fruitful function, I don't know why that produces a fruitful function. Who calls it that? Is one that produces a result or return value. All right. The return statement ends the function execution and sends back the result of the function. The fruitful function is the one that produces a result. Okay. The return statement is successful. Let's just call it successful. A successful. I mean, I guess a successful function. Successful. Yeah, I guess that's the truth. A return statement ends the function execution and sends back the result of the function. Technically, I mean, we went over what a return statement is, but we can go over it again. Let's get this out of the way.
Values.
Let's do that. All right, so right here we've got def greet lang. Okay, so lang is the parameter, right? So if lang equals s, we're going to return hola. If lang equals else if lang equals fra, we're going to return bonjour. Else, we're going to return hello. Okay. So it's just like before. When we say greet in Glenn, it'll say hello, Glenn. Greet S Sally, it'll say hola, Sally. And then when we do FR, greet FR, we'll do greet FR Michael. We'll say bonjour, Michael, or something like that. So yeah, these are the return statements. That's the point of this. So it's going to say hello, bonjour, or hola here. Okay, there we go.
Is fruitful because they produce something, and but you don't have to. You can just say return, or you don't even have to have a return statement. It goes to the last line of the function, and it does a return automatically at the last line of the function. So here's a little bit of a rewrite of our little language program. We are going to create a greeting program. We're going to take the language as the first parameter. And instead of just doing a print statement, which is what we did before, this is now more like a function because it takes some input and produces some output as a return rather than just printing. It's a little tacky for a function to print. And so here we return hola, bonjour, and hello based on the right thing. So now we say print greet en, so it runs the code once. Lang is en, and then runs this code, and the residual value is hello, so it says hello Glenn. And similarly, when it runs this code, it passes ES in as lang, it runs through, and it runs this statement. It does. If there was more statements, it wouldn't run them. As soon as this return runs, that says that this bit right here is now HOLA. So hola Sally. And the same with French. Goes in, runs again, out comes the return statement, and then bonjour Michael. So you see how we can control as we're writing the application. We can control as we're writing the function what the residual value that we want to see in whatever expression is calling us. Sometimes we have returns and sometimes we don't have returns.
Gotcha.
So
let's see what we got here. Arguments, parameters, and results. We'll just watch this. Look at this one. So big equals max hello world. And as we remember, it's going to be a W because first is going to be the space at 20. And then we've got the capital letters at whatever numbers. And then after that, it's the lowercase. And this is the biggest lowercase, right? So we're saying print big. Print big. So it prints W. There we go. What is the point of this? Arguments, parameters, and results. Okay, so we've got the argument, hello world. Yes, this is the argument for the max built-in function. Here's the def. Okay, so max INP. I don't know. INP. Blah, blah for X and Y, blah, blah. Return W. What? Anyway, that's not. Oh. Anyway, so it's going to return W after going through all kinds of stuff. It'll actually be like return a variable that we go through. But this is such a, anyway, whatever. So it's going to say return W after doing an actual function. This is so made up. Poorly made up. But you know what? It's hard to be a university teacher. Parameter. This is the parameter right here. INP, whatever. Well, let's go.
So if you think of the max code that we talked about before, we can kind of see that somewhere inside that max code, there's a return. And that's how it communicates the W back to us. So we pass in his argument, hello world. It comes in as a parameter, and it's going to loop through this imp somewhere. It's going to loop over and over into imp. And then at some point, it's going to figure something out and tell us what it wants to send back to us is a return statement. And so the W comes back and gets assigned into big.
True.
You can have more than one parameter.
All right, let's do this. 2 minutes, 35 seconds, so maybe like 5 more minutes. Jeez, it's going to be like an hour-long video. I'm going to have to edit this so hard. Let's go. What are we doing? Let's grab this. All right. So what did this say? Multiple parameters arguments. All right, let's do that. Multiple parameters / arguments. Okay. We can define more than one parameter in the function definition. All right. Yes, we can define more than one parameter in the function definition. Very true. Just like this right here, we've got add to, we've got parameter A and parameter B. What do we pass in? Like right here, parameter A is going to be 3, and then parameter B is going to be 5. So it's going to be 3 plus 5, which is going to give us 8. All right, so that's how that works. We simply add more arguments when we call a function. All right, so yeah, they're just comma separated values inside of the parentheses. And then what else? We match the number and order of arguments and parameters. We match the number and order of arguments and parameters. Huh? What? Number in order. Well, let's have him tell us what that means.
And they're just in order. The first one and the second one, 3 and 5. So 3 becomes A and 5 becomes B. And away we go. So we just use this to add 2 numbers. And so 3 plus 5 is 8.
True.
So you get as many as you like. And the order matters. And if you do things like you tell it you want parameters and you don't give it to them, then that'll become a traceback. And it'll blow up.
Why does the order matter?
Talk about optional parameters later. So you don't have to have return values, and
I don't want to ask ChatGPT. All right, so let's come back over here. We're going to do this void functions. All right, void functions. All right. So when a function does not return a value, we call it a void function. Okay. Functions that return values are, I'm not going to call it that. Successful functions. Successful. Voids. Let's not call it that, though. I don't want to call it fruitful functions. We're just going to skip this. Void functions are not fruitful. We'll just skip both of those lines. How about that? I just don't want to call it fruitful. I don't know why. It's just anything that has anything to do with indoctrination or anything that slightly resembles something that I would consider indoctrination to a questionable way of thinking. I'm going to leave that stuff out. You get what I'm saying? Hopefully.
That means that you simply don't call return with a value, and return is always implicitly happening as the last line of the function. So that's.
All right, let's do this. I thought I was going to get like a break of like at least a few minutes, but nope. We only have a few minutes left. All right, so let's do this. To function or not to function? When to use functions? When to use functions. Organize our code into paragraphs. Okay. Capture a complete thought and name it. I'm going to have to watch this whole freaking video while I'm editing. So don't think you're the only one bored. Don't repeat yourself. All right? DRY, dry. Make it work once and then reuse it. That's how programming usually is. If something gets too long or complex, break it up into logical chunks and put those chunks into functions. All right? And then the last thing, make a library of common stuff that we do over and over. All right? Perhaps share this with friends. We may perhaps share this with friends or colleagues. I don't know if that's how you spell it, but that's how we're spelling it right now. We can. Let's put we can. Don't repeat yourself. DRY. DRY. All right. Make it work once. We make it work once. And then we use it. Organize our code into paragraphs. Capture a complete thought and name it. True. Okay. So yeah, this is basically what it's saying. Like, organize our code into paragraphs. Capture a complete thought and name it. Interesting. I might consider that actually.
Kind of the basics of how functions operate, but I don't want you to get too excited about writing functions. Some programming classes are like, gotta write a function, gotta write a function. Functions, to be clear, are a very powerful mechanism. And as we write programs, 150, 200,000, 200 lines of code, 1,000 lines of code, 10,000 lines of code, the concept of a function is really important. We would go crazy if we didn't have functions. But if you're only writing 20 lines of code, forcing yourself to write a function is kind of pointless. So don't worry about the maybe the lack of urge to use this. We are calling lots of predefined functions, and we will for the next couple of lectures. There will be a time when you go like, oh, I'm sick and tired of repeating myself. Oh yeah, time to write a function. So that's why we don't push functions prematurely. We just want you to know what they are, use them, and at some moment you'll be like, oh, I want to define one. But don't worry about, it might take a while before you really want to define a function. So that kind of summary.
There we go. So let's cook up the summary and go over the summary points and then get out of here. Freaking hour, 1 minute. God, please. All right, let's do this. Summary. Arguments. Summary. Arguments. Arguments. Okay. What are the arguments? They are the one sentence. Arguments. The values passed into a function call. Function calls parentheses, basically. All right. Results. The things that come out of functions, stuff that comes out of functions, stuff that comes out of functions. All right. Void functions. I don't remember. When a function does not return a value, functions that don't return values. Okay. Functions that don't return values, right? Why use functions? To avoid repeating ourselves and to make the code easier to understand. Right? I guess that's what that stuff was saying. Functions. Functions. Basically dynamic variables. Basically dynamic variables that do things when outside using, do things sometimes using input from outside sources. All right. What else do we got? Built-in functions. Built-in functions. All right. What are those? They are the functions that that the language, there's two G's. Okay. Language, the functions that the language preloads in its own library. Something like that. What else do we got? Type conversion, int float. Type conversion, int float, string conversions. Are those examples? Oh, so let's do this. So stuff like int, examples, ex, int, float, print, etc. I had etc. ECT on the last one, whatever, etc. There we go. All right, so let's go here. And what are parameters? Parameters. The variables used locally inside of a function declaration that equal the arguments passed into the function calls. There we go. I guess that makes sense. All right, so there's that. There's the summary. Let's listen to him say it.
Summarizes our lecture on functions, and up next we're going to do iterations.
We're not. All right. We're not. All right, so there's that. So there's what? Well, anyway, there's that. So now we're on to exercise 1 for this one, and we'll see you next time.